Okay. If you guys take a look at this graph right here, this is the kind of graph you guys are going to be doing. So if you look, you will notice right here, so you need to look up at the board, right here at this 2, notice how there are 2 points there. One of them has a closed dot, one of them has an open dot. See that? Mm-hmm. And then the graphs look a little different. That point, right, the point of discontinuity happens right here at the x equals 2. What that means is it's not one continuous graph. There's like a break. There's part of the graph that goes this way, but then it jumps up here and then the graph goes the other direction. So at x equals 2, it's not continuous. That's what the point of discontinuity means, is it's just not continuous. So if you read down here at the bottom, it says, up until now, we've been looking at functions represented by a single equation. But in real life, most functions are represented by a combination of equations, each corresponding to a part of the domain. So these are called piecewise functions. You're going to have several different pieces to the graph. Okay? Turn the page. Okay, so a piecewise function is a function that is a combination of one or more functions. The rule for a piecewise function is different for different parts or different pieces of the domain. For instance, okay, so this is one that you guys should be familiar with. Ticket prices are often different for different age groups. So the function for a movie ticket price would assign a different value for each domain. So for instance, you know, if you have kids where their age is less than 2, you know, they might be completely free. You know what I mean? Like, you wouldn't have to buy them a ticket. Okay, they would cost 0. Then they might say, you know, between the ages of 2 to, I don't know, let's say, that's not an equal sign. Between the ages of 2 to 12. So then the age would be here. If their age falls between 2 and 12, so it can equal to or be less than 12, they would have like a child's cost, like a price for a children's ticket, which is usually cheaper than an adult, right? Yeah? Mm-hmm. So then the adults, you know, the adults may start at age 12 and go up to 55, because then what usually happens at the age of 55? There you go, the senior price. So their age would be greater than or equal to 55. So most functions in the real world have different pieces to them because it's not usually very continuous. It's just, you know, these people will be a certain price, these people will be another price, these people will be another price, and so on. Okay? So when we go to do graphing for piecewise functions, this is what you're going to look at. This is what it's going to look like, I should say. So if you read this piece of the function, it says if x is less than 1. So for any number less than 1, 0, -1, -2, this is the function we're going to use. But if x equals 1 or is bigger than 1, so like 1, 2, 3, 4, this is the function we're going to use. Okay, so what essentially you're looking at, here's an x and a y axis. Draw this for me, x and y. The point of discontinuity happens at the 1, right? Can you guys look up, please? Mm-hmm. They have different functions at 1. So over here, let's just say that's where the 1 is. For x being less than 1, we're going to use this function. So the half x plus 3 we would use on this side of the graph for anything less than 1. And then for the negative x plus 3, we would use that over here for anything greater than 1. So you're going to use different functions depending on what this says. If it's a number less than 1, we'll plug it in and it should land on this side of the graph. If it's bigger than 1, we'll plug it in and it should land on this side of the graph. Okay, it even says that. For all x's less than 1, we're going to use the top function and it should be on the left side. And then for anything bigger than 1 or equal to 1, we're going to use the bottom function and it'll be on the right side. Basically what this means is we're going to have to make a t-chart for like this, and we'll make a t-chart for this. So we're going to have two little t-charts. Sorry, right here. We're going to have a t-chart for this function. So like I might use 0, -1, and -2. And then I'll have a little t-chart for 1, 2, 3. The numbers that equal to 1 or are bigger. Okay. All right, go ahead and flip that over for me. Okay, this is the same type of thing here. So like draw an x and a y axis. It doesn't have to be perfect. We're just doing a little sketch just to kind of get an idea here. What is the point of discontinuity? Like what's the number where things are different? What's the x value?
-2.
Okay, so -2 would be like over here, right? That would be at the -2. So for any number less than or equal to -2, so this side of the graph, what function am I using? What expression? You guys, it's right there. Just read it. What does it say? No, for this one, for the left side of this, what expression am I using? What does this say, you guys?
2x minus 1.
We are going to use 2x minus 1 for any number less than or equal to -2. But for any number greater than -2, what function am I going to use?
3x plus 1.
There you go. 3x plus 1. Okay.
That's how we do?
Well, we're going to do it. We're going to actually do it down here. Okay, so we're going to graph a couple together so you can actually see what this looks like. All right. The point of discontinuity is 0. Okay, so when we go to make a t-chart, I need you guys to do this. We've got an x and we have a y. The middle column is going to be where we show our work. If x is greater than or equal to 0, okay, so give me the first 3 numbers. If it can equal 0, I'd have 0, then what? Give me the next 2 that come after 0.
1 and 2.
1 and 2. We are going to use the 2x plus 3. Okay? So you guys are about to do some plug and chugs. So you need to be paying attention. I'm going to do 2 times 0 plus 3, 2 times 1 plus 3, and 2 times 2 plus 3. You are just plugging these numbers in for x, and we're going to solve it and get an answer for y. So you guys tell me what those are.
3.
Yep, 3.
4.
I
5.
5.
And then 7.
7. Okay? So this is what I need you guys to do. Okay, now, before you plot these points, you need to watch. You need to watch. Because this had an equal sign at the 0. I don't know if you guys remember this from Algebra 1, but when there's an equal sign, you make the dot closed. So at this 0, 3, 0, 3, you want to make that a closed dot. If that equal sign had not been there, what kind of dot would I make?
Open.
Open. Okay, but we're going to make a closed dot there. Now the rest of them will all be closed. The only ones you have to worry about are the ones at 0. Okay, 1, 5, and 2, 7. So you take your ruler that you all got. Now look, this is just a piece of the graph. So this is the starting point. You do not want to go past that, you guys. You want to just start here and just show the up. Okay? There wouldn't be anything back here because we are only looking at numbers starting at 0 and bigger. So you don't want to make that a full line. Now we need to focus on the numbers that are less than 0. Now we're still going to start at 0 because we need to know what the 0 would be. And then what would the next two numbers be less than 0? Like what comes after 0 in the negatives?
-1.
-1
-2.
and -2. So for anything less than 0, we're now using the x plus 4 function. So I'm trying to do this in different colors so you guys can like follow everything I'm doing. Okay, we're going to do, in the middle, I'm going to show the work. So like I would do 0 plus 4, -1 plus 4, and -2 plus 4.
4, 3, and 2.
Okay, good. Now, this symbol right here, did that have an equal sign? Right there.
No.
No. So since this 0 did not have an equal sign, our 0 is going to be an open point, an open circle, whereas this 0 up here was closed. Okay, so at 0, 4, hope you're watching, at 0, 4, you want to make an open circle. You don't want to color that in. And then all the others can be closed. So -1, 3, and -2, 2. And that's all you need. I'm only going to make you do the first 3.
Wait, and then -1. Can we circle in the other two?
Yes. The only one you ever have to worry about is this one right here. The very top one, the 0, because that's the point of discontinuity. And normally what should happen is one should be open and one should be closed. So see, now you've got two pieces of the graph. You had the piece that started at 0 and got bigger, and then you had a piece that started at 0 and got smaller. So this should never be, since it's called piecewise, there should be separate pieces. You should have one piece going one way and another piece going another way. And at that point of discontinuity, if both of those would be closed, that wouldn't even make sense. Because it's not continuous. You guys okay with that?
Mm-hmm.
All right, turn the page. We're going to do a couple more together. Okay, so the point of discontinuity on this one is what? What number?
-3x.
What number is the number that both T-charts are going to start with a 1? Well, but I'm doing this top one first. The top one says less than or equal to 1. So less than 1 would be what? 1, 0, -1. Okay? Now, that has an equal sign. So this top one right here, is that going to be open or closed?
Closed.
That's going to be closed. You'll have a closed circle there. And we are using the function -3x minus 1 to get all of our y values. So you're going to take these numbers and you're going to plug them in where the x is. So we would do -3 times 1 minus 1. We would do -3 times 0 minus 1. And -3 times -1 minus 1. So what are my answers? Like, what's -3 times 1 minus 1?
-2.
This would be -3 minus 1 would be -4.
Oh, yeah.
And then -1, 2. Okay. So let's go ahead and plot those, get that portion done. Okay, so at 1, -4, it should be closed. Make sure you make, hey, 1, -4. You go to the 1 on the x and then down 4. I think you did it backwards. Yeah. Okay, then for 0, -1, that would be here. And then -1, 2 would be here. Okay, so remember, this is our starting point and it's going up to the left.
-1.
Can you hit that first light switch, the one closest to the door? Thank you. Yeah, that's better. Okay, so now, since we've taken care of the top one where everything was less than or equal to 1, which means it was to the left, now we're going to go and we're going to figure out all the greater than ones. So these are the greater than 1. We still want to start at 1, but then we'll have 2 and 3. Now this function's interesting. What does it say?
-5, comma.
It just says -5. It doesn't even have an x involved, does it?
This is 1 minus 5?
No. If they're telling you that you're going to use a -5 for all of your x's less than or greater than 1, there's no work to be shown here. There's no work. They're just telling you that for no matter what your x is, the y is always just going to be
-5.
-5. So you're just plugging in, or you're not even doing a plug and chug. They gave you the y value. It's a constant. Now, because this was greater than with no equal sign, this point, should that be open or closed?
Closed.
There,
Open.
it should be open. So at 1, -5, you are going to make an open circle. 2, -5, 3, -5. Isn't that just creating a horizontal line? Just going straight across? Yeah, whenever you have the same y value. So you can just follow the grid line there. So piecewise functions, you should always have a break in your graph at that point of discontinuity. So this middle column wasn't even needed because there was no x. Now, if there had been an x in there, if that had said x minus 5, then we would have had to subtract 5 from all those. But since it just said, since it just said a number, that was the y value. All right, the one down at the bottom. How many different pieces to this graph do we have? Doesn't look like 2.
Three.
Thank you. There's anything less than -4, that's 1 piece. Then between -4 and 1 is another piece. Then between, or anything bigger than 1 is another piece. Okay, let's see how this goes. Let's start with the top one. Make your T-chart. We're starting at -4, and it says less than -4. So tell me the next 2 numbers less than -4.
-5 and -6.
Okay. Now for this function, we are using x plus 4. So we would take -4 plus 4, -5 plus 4, and -6 plus 4. 0, 1, and 2. Okay, now remember, look up here. This whole section was for anything less than -4. There is no equal sign, right? No equal sign, which means that point will be open. So the very first point you plot, -4, comma 0, which is right here. Oh, right here, I mean. Open circle at -4, comma 0. Oh, wait a second, dear. Hang on, these are negatives. You didn't put negatives here. -5 plus 4 is -1, and -6 plus 4 is -2. Okay, so -5, -1, and -6, -2. So that was the starting point, and then it's decreasing. So when you put your ruler down, make sure you actually show that. Like it needs to start at the open circle and then just draw the arrow going down. That's the first piece. I'm going to try to do each piece in a different color so that way it kind of shows up a little bit better. Now this one, the -4 to 1, I'm going to make a little T-chart up here. Okay, so for this piece, if it says -4 to 1, and see how they both have equal signs? Won't both ends have closed dots then? Okay, if they give you one where it's between 2 numbers, those are the only 2 numbers you have to use. We'll just do -4 and +1. Otherwise, I want you using 3 numbers total. Okay, but since these are just endpoints, between those, we're going to just use those. And both of them will be closed because they both had equal signs. That one says to use the function 2x plus 5. So we're going to do 2 times -4 plus 5 and 2 times 1 plus 5 to get our answers. Mm-hmm. Yep. Okay, so these are for, this section right here is for the numbers that fall between -4 and 1. So at -4, -3, you're going to make a closed dot. And then at 1, 7, you're going to make a closed dot. So that's another section, and all you guys have to do is connect it from point to point.
Wait, where are we putting them?
-4, -3,
Oh.
and then 1, 7. And that is not going to be an arrow. That is just the middle section, so it's just from end point to end point. It would not keep going, because that's got a starting point and an ending point.
And we're filling both of those up?
Yeah, because they both had equal signs. Remember? Up here, both equals. And then that's just, these are endpoints, because it only goes from there to there. Then our last piece is for any number greater than 1. So since it's for anything bigger than 1, we have to do 3 numbers, and this will keep going. So we will put an arrow on the end. So we have X, we have Y. We're going to start at 1, and we're going to go bigger. So it's like 1, 2, 3. That one says to use negative X plus 3. So we would do like negative 1 plus 3, negative 2 plus 3, and negative 3 plus 3 to get our answers. So negative 1 plus 3 is 2, negative 2 plus 3 is 1, and negative 3 plus 3 is 0. Okay, now since these were for anything greater than 1, our first point will be open because it did not have an equal sign. So when we plot 1, 2, which is right here, open circle. 1, 2. Then 2, 1, you can close that, and 3, 0, you can close that. So now that's starting there and decreasing. That is a piecewise function. And anytime you guys have these, this is what's going to happen. If you look at, so can you guys look please? If you look at this piece, notice how it gets up here, there's an open circle, and then it jumps down, closed circle. Then it goes up, we have a closed circle, then when it jumps down, open circle. On each point, like right here at x equals 1, 1 should be open, 1 should be closed. At negative 4, 1 should be open, 1 should be closed. Because if they were both closed, they would be continuous, and it's just not. So you have 3 different pieces. All right, go ahead and turn the page. Now they want us to evaluate f of x when x is 0, when x is 2, and x is 4. Okay, so this is what I need you guys to tell me. If x is 0, would it fall in this category or the other category?
The first one.
The first one. So if we're doing the x equals 0, we're going to use x plus 2. So we're going to just plug in 0 plus 2, and what do we get?
2.
Okay. Now for x equals 2, which category would we use? The top one or the bottom one?
Top one. Bottom.
It says equals 2. So isn't it that one?
Mm-hmm.
This one has the equal sign. So when x equals 2, we would have to use the 2 times x plus 1. So we would have to do 2 times 2 plus 1.
That's 5.
That's 5. And then for x equals 4, are we using the top one or the bottom one?
The bottom.
The bottom one because it's bigger than 2. So for x equals 4, we would use the 2 times x plus 1. So 2 times 4 is 8, plus 1, 9. Yeah, evaluating these is a lot easier. You just have to figure out, am I using the top function or the bottom function based on what this says? Okay, so we're going to do one more, and then I think that's the end of the notes before I give you guys your practice page. Okay, so negative 2. Would I use the top one or would I use the bottom one? Top. So we're going to do 2 times negative 2 plus 1.
That equals negative 5. Oh wait, Negative 2 times 4 is negative 4. Oh,
Negative 3. Okay, how about f of 0? Which one would I use?
3. Top.
It's equal to 0.
Bottom.
Bottom because of the equal sign. So I would do 2 times 0 plus 2.
That's 2.
Uh-huh. And what about the 1 and the 5? We're using top or bottom?
Bottom.
Yeah, because aren't 1 and 5 both bigger than 0? Okay. So we're going to do 2 times 1 plus 2 and 2 times 5 plus 2.
So it's 12 and 4.
Yep. That right there is the end of your notes.